Hi everyone. So I am Chandrasekhar P, Assistant Professor, Department of ECE, ATMI College of Engineering. Today I am going to give a session presentations on the detecting an error using an CRC CCITT from an computer networks lab. CRC means what? So CRC stands for cyclic redundancy check and CCITT stand for Consultative Committee for International Telephony and Telegraphy. Next, so before going to a program of a CRC in C, let us first discuss what is this CRC means. CRC is a technique for detecting an errors in a digital data, but not for making a correction when errors are detected. It is used primarily in data transmission. Cyclic redundancy check in C programming is an error detecting commonly used in storage device. Block of data is entered and is checked, and it is based on if the remainder is 0 or not. And if it is not found to be a 0, then error is detected in the code. CRC are popular because they are simple to implement in a binary hardware. Basically, CRC uses XOR operation between two numbers. If the remainder is 0, then there is no error, and if it is not 0, then error is detected. So we'll see the how this CRC is generated and how it is checked. So here is a small figure which represents a CRC generator and a CRC checker. So if you want to generate a CRC checker, we need a data. Along with the data, we need an n bits. So when these are divisor, then we get an CRC. So the total data plus n bits what we are going to use is called as n data, and in CRC what we are going to add. So the combination of data plus CRC are transmitted to the channel, and at the receiving end we need to check that. So that is what we call as an CRC checker. That means at the sender we generate an CRC and we attach to the data of an data plus n bits. At the same time, when we are going to receive, we need an CRC checker where it has an data plus n CRC. So that data plus CRC is divided from the message signal, and those message signal, if the remainder is 0, then it is an no error. If the remainder is not 0, it is an error. We'll come to an algorithm. So before going to an algorithm, we'll see how the calculation part is done. So here we are going to consider a generator polynomial and a message polynomial. So this is the sequence example of a generator polynomial 11011, and this is then a message polynomial 11100101. So you may ask, what is the extra what we have been added, the 4 zeros? This is nothing but the generator polynomial minus 1. That means n bits of data what I am going to append while during the transmission. So that is what we with the along with a message. So how to append these zeros? This zero is appended depends upon the generator polynomial, what is number of bits in a generator polynomial. Suppose if I take the number of bits in a generator polynomial is an n, then the appending zeros to the message sequence is an n minus 1. For an example, if an n is equal to 1, then it is an n minus 1, that is the 4 minus 1 is 3, so 3 bits of. So here in a generator polynomial, the bits are of n 5 bits, so 5 minus 1 is an 4, so 4 zeros is appended to the message, and then we are going to see whether there is an error or not. So to do that calculation, we are going to perform, as I said, that we are going to perform an XOR operation between two numbers. So first the digit is 1, we are going to consider this 1, and 1 into, that is as in 1 into 1 is 1, 1 into 1 is 1, 1 into 0 is 0, 1 into 1 is 1, 1 into 1. Next we perform an XOR operation The XOR operation is whenever the inputs are different, the output is an high. Whenever the inputs are same, the output is an 0. So here the output is 0. Here the output is 0. Again 1 1 0, 1 0 1, 0 1 1, 0 1 1, and this will be taken for an next calculation. Next again, here we are going to put in 0, because here the whatever the value that has been obtained, that same value is going to consider here. So here 1 1 is 0, so this is deleted and going to consider. So 0 into 1 is 0, 0 into 1 is 0, 0 into 0 is also 0, 0 into 1 is 0, 0 into 1 is 0. Finally the output is what? 1 1. But is performing an XOR operation, we get 1 1 1 1, and this 0 is taken downwards. And again the next is what? The starting bit is an 1, so we are going to multiply with an 1, and 1 into 1 is what? 1, 1 into 1 is 1, 1 into 0 is 0. So similarly we are going to perform the same thing, and we check for an remainder. If this remainder is an 0, then there is an error free. If not, then we are going to say that the message whatever have been sent is hasn't got an error. Next we'll go to an algorithm of it. So how this algorithm works? First we need to read the data frame, that is the message that is to be transmitted from the user, and next suffix the 16 zeros to the message bit, that is the bits of an 0, and perform an XOR operation between the checksum bits and then suffixed messages, and transmit the output bits of an XOR, and read the received string, verify the message that is received at 1 at the sent at and 1 that sent. If both messages are not same, then display an error message, else no error message. So next we'll come to a programming part. In this programming part we use an standard io.h, standard io.h, that is an header file starting with the including with an header file which is defined with the printf and then scanf statements, and then we input the first number in an array, usually the large numbers and usually a large numbers. For an example, if I take an 8 digits of a number, that is 10100001, and then second number in an array div, if entered usually a smaller than the first number. In this example 4 digits, that is 100, after an input of a both the numbers, few zeros are added at the end of the first array, and the number of zeros are equal to the number of an digits in the divisor minus 1, as I said that in an previous. That is the number of message, that is what we are going to append in 0. It is nothing but the generator polynomial bits, that is n minus 1 bits. Next, then after this when we are going to, this is the GP is a generator polynomial, and these values, binary values, are nothing but it is the sequence, that is the generator polynomial g of x is equal to the coefficients of x values. So I am going to consider a 16 bit of n value, so hence 6 to the 16 powers x to the power of 16, the coefficient is 1, and x to the power of 15, there is no coefficient, it's then 0. So similarly we have written the 16 bit of n generator polynomial. Next we ask to enter the length of a data frame. So those data frame is stored in a variable called as a length, and next enter the message which is going to be transmitted. So to read this message I have gotten a variable which is similar to them. I need to check whatever the message I am going to, it should not exceed more than the length of a data, hence I am going to compare with an I is less than or length. That means by using this line it will limits the whatever the number of length of a data I am going to be entered from the keyboard. So those values are get stored in a variable called a. Next, appending of an 16-degree zeros to the message bit. So message bit you have taken, I need to append, which depends upon the polynomial, and after appending the message bit, next we'll check for an 16 bit of an data. So next we check for an a length. If this no frames times to be divided, then the message will be an length minus 16. If the frame is divided, it calls the void function, that is division function. This division, the void divide, is an used to calculate what is the count of a variable that is going to be added. That is what is the count of a variable that has been performed between one number to another number. And if not, After doing that, next again I am going to check the what is the length of the thing, length of the data have been entered, and we do the XOR operation. If then XOR operation at the final, if the next data is going to be transmitted. So once the data is transmitted, if you give the same data, then at the receiving side data, then it will check for whether there is an error or not occurs. If the error is not occurred, then it prints an error is received data. So if error is not occurred, then it prints an data received is an error free. That means whichever we have been transmitted, that is should be equal to a received data. If the data what I transmitted is not equal to a received data, then I am going to print a statement called error in received data. Next comes with a output window. So how this? So first what I'm going to do, I'm going to enter the length of a data frame, that is n 4, and I'm going to say that enter the message bit 1010. So once I have done with this, so it start executing the, it calls the div function and it start executing the lines. That is, it will start executing and it at the end it is going to be give the data that is to be transmitted. So in this data, if I vary any of the one bit, then the data received is an error, that is error in an received data. If none of the data doesn't that is the data what have been transmitted is matched with then what the data has been received, then we are going to print a data received is a error free. So this is about how the CRC is done, a small thing in an C programming. So please if you like this videos, please comment on the videos and also give a like, and also get subscribed to our channel Atmiya Electrocrats. If you have any doubts, bring us or reach us by an email ID atmiyaelectrons@gmail.com, and don't forget to click on the bell icon. Thank you. So in connection with the CRC program explained in an last theory session, now I'm going to show the execution of an CRC. So to execute, once again create a text file with an extension .c. So right click on it, select an new document, in that select empty document. So give the file name crc.c, because I'm writing a program in an C programming, so hence it is an .c program. So already I have gotten a CRC program, so paste that I have been already having. So once again, this is the code what I have been explained in a theory part. So how the CRC is going to be that is how the CRC program is going to be executed. So now save the file, go to a file and save the file and close it. So once again open the terminal. In an open the terminal, right now I am in a desktop. So on a desktop, if I say ls, it will show list of files and folders. In that, the crc.c is the file which have been which is the file that has to be executed right now. So to execute that, first I need to do the compile. That means I need to convert this file into a machine level language. To do that in an Unix in an Linux Ubuntu environment, I have got a compiler command called gcc space file name is crc.c. So this will convert into a machine level language. Once it is converted to a machine level language, now I need to execute those value. So that value defaultly it will be in an a.out file. To run that a.out file, I have an instructions or an steps, or I can say the protocol, that is ./a.out. So this will execute. Now it is asking for enter the length of a data frame. So that is what the first line says, that is enter the length of a data file. I'm going to open that. So this is the program where it is asking to enter the length of a data frame. So that length of a data frame will be stored in an ln. So I will write the length of the, I will type the length of the data frame is around 15, sorry, will take some, just a minute. So 4 have taken example, so we'll take the same thing, 4. Next it is asking to enter the length. That means this loop is going to be executed next. This loop is going to be executed next. That is, I'm going to enter 1 space 0 space 1 space 0, or else I will do one thing. I will take the example whichever have been explained in an theory itself. So what is the message, what I am going to take, once again I rerun this program. We'll finish off this with the whatever have been done. So message bit is 10101. So 1 space 0 space 1 space 0. This is the enter message bit. So once the enter message bit is done, so I will say enter. So this is the data which has been calculated. Now you can guess from where I got this. This is nothing but the coefficient what I have been taken, that is 100 is going to get divided, that is going to get divided by the polynomial what I have been taken. So that when it results in an either whether it is an error or an, that is which is an a transmitted bit or an not. So here transmitted bit. Now the same thing we'll see. So whatever I've been transmitted, the same thing I am going to be received. So I will give the received data, that is 1 0 1 0 1 0 1 0 0 0 0 1 0 1 0 0 1 0 1 0. So which is same as in the received data what I have been entered is same as in a transmitted data, is it? So the message will be displayed as an there is an data received is an error free. Next we'll check for one more condition. The same thing, the 4 message bit is 1 0 1 0 and it is a transmitted. Now I am going to alter the values of it. 1 0 0 0 1 0 1 0 0 0 0 1 0 1 no. So in this where I have been modified some changes. Instead of in a third bit, instead of it is an 1, I have given an a 0. Now if I say to check the ERC, it will shows that error in an received data. So this is a simple program of an how to check an error. Whatever I have been transmitted has got an error free. Here we are just doing to detect an error is present or not the data. So to create and transmit an data itself, I am going to do the calculation of a polynomial and a message, and after doing that I am going to be add. So next we'll take an same example of one more example, that is an of this one. So here the generator polynomial is 11011. So to give that modification value, what I need to do, I need to change here. So we'll change the value of this. So what is the value? It's an 11011. 11011. So this is the value what I'm going to be given. And this is the generator polynomial. And next what I need to do, I need to enter the length of the frame. So length of the frame is how much here? I'm going to take in 1 2 3 4 5 6 7 8 bit of an data. So the length of the data is an 8 bit. Next what is the message bit I'm going to consider? I'm going to consider 111100101 as a message polynomial. So right now we'll execute the same thing. What I need to do, I need to save the file, go to a file, so select the option save and close this file. Next navigate, so first clear this window of a terminal, and next give the type command to compile the things, that is from an to an machine level language, gcc space crc dot c. So it has been error free in the program. So we'll run the executable line. To run this command, we have an dot slash a dot out. So the same thing I'm going to show you. So what is the length of a data frame? So what is the length of a data frame? What I have been entered is an 8 bit of n data. Is it 3 3 6 7 8 bit of n length of a data? So what are the message bits? That is 11100 11100. Next it is 101. So apart from this, if I give also, it will consider, but for an do the calculation, that it considers only an 8 bit only. So to this message bit I need to append the value. So to append the value, what I need to do, whatever the value that is going to be added in a polynomial generator polynomial, it should be -1. Suppose if the generator polynomial is an n bit of an data, the appending of a 0 should be an n-1. So in our example, we have considered how many bits? We have considered the message polynomial, generator polynomial of an 5 bits. So hence we need to append that 5 minus 1 is an 4. So we need to append how many? I have 4 zeros. That is 1 2 3 4. So after doing this, what is the process is going to be done? It's going to, after adding an appending of an 0, it do go for a division, it do the XOR operation between an two numbers, and it results in an what is the data to be transmitted to the channel. So this is the data what it is going to be transmitted to the channel. So to whether to find whether it has got an error or not, the same thing what I need to do, I need to do that same, I need to enter. So that is 1 1 1 1 1 1 0 0 1 0 1 0 1 1 0 1 0 0 1 0 1 0. So this is the data. If I say enter, if it is an error is occurred, then it will show. That is means error occur means if the data what is transmitted is not equal to the data what have been entered. If it is an not matches, it gives an error. If it is matches, it gives an error free. So let me check that. So 0 2 4 0 2 4 0 2 4 2 4 0 0. So error is received data because I have modified the values. So this is a simple thing, demonstration or an execution of the CRC program. So please do like the videos and give a comment on this, and also get subscribed to our channel Atmaya Electrocrats, and don't forget to click on the notification bell icon notification to get a notification of the all the videos. Thank you.